Hello everybody and welcome to another Unity game development video. Today I will be talking about the firing system I have for the weapons in the game. I've been trying to kind of shorten these videos and just get the relevant information out there, so I'm just going to get right into it. I am creating a Unity first-person shooter, and today I'm going to be talking about how these projectiles are spawned and how they work and how they interact with the environment, specifically how they hit, reflect, and deal damage. So, as you can see, I can shoot them, and they may reflect, but they don't always reflect. They'll reflect at steeper angles and less likely to reflect shooting head-on. They also will deal damage to enemies, either by hitting a body or an assigned hit point or a weak point, which in this instance is the head. So there are damage modifiers. So I'll hit the body or the head and it'll do more damage. And they can pierce, so I can line these up. And I'll hit about 3 of them right there. So there is piercing with a reflection system in place as well. So if I jump out of here and I jump into the script, the two relevant scripts we're going to be looking at today are the weapon script, which handles the weapon, and in the firing function, we're going to see that a game object bullet is being instantiated, and then all the information pertaining to that bullet is being assigned from the weapon script. So the bullet has a damage, head bonus, reflection angle threshold, and VFX variables, as well as the range, and all those are being assigned from the weapon to that new bullet game object as it's being instantiated. So everything is pretty straightforward here, except for the reflection angle threshold modifier is essentially a floating point number that is added onto the required angle, added onto the random number that is being referenced against the required angle number. So if it requires that the randomized number be above like 90 or something like that, essentially it's going to add onto the randomized number and has a higher chance of getting past that threshold and reflecting. So it is instantiating that bullet, and if we go to the bullet component that is attached to all of the objects that are spawned, essentially when the bullets are being spawned, they're an empty object with a trail renderer attached to them. So we spawn the bullets and a force is applied to them. If we go to the bullet, we see it has its rigid body, and then we are essentially adding a force onto that bullet. This is randomizing several floating point numbers to randomize the kind of spread of the bullet. There are magnitudes here, and those are being affected by the current accuracy of the weapon. I may have covered that in another video, but if I haven't, I am sorry, but I will get to it in a different video because it's its own kind of thing. But it's spawning the bullet, grabbing its rigid body, and then adding a force to it. What we're going to focus on today is how the bullet is detecting what is in front of it. You may think that the bullet is, or that the gun is shooting a raycast forward and it's detecting what the bullet's going to hit in any given moment, and that the bullets are moving so fast you might think that they are just essentially raycasts, but they are physical objects. So essentially the bullet is moving forward. If we go into Photoshop here, it is at one instance we are taking the time of the bullet, not the time, but at one time we are taking the position of the bullet, and a second time we are taking the position of the bullet again, the same bullet. In this instance, we are doing it between frames. So we take the position, we update one frame, and then we take the second position, and we are drawing a ray between them. And we are grabbing all the information in between those. If the normal that's detected in there, once we randomize the number, if it fits the angle described, then it will reflect it. If not, it'll go through it. And if it detects that the object in the middle has a hitbox, and all the necessary components, it will apply the damage to it by accessing that character's player manager script and running the function that affects its health. So we can see that here in the script. What is happening is if the first position doesn't exist, so if the bullet was just instantiated, position 0, which is the first position, is going to be set to the initial position of the object. So as the bullet spawns, we're getting that first position. We're waiting for the fixed update, and then we're grabbing the second position, and we're running the raycast all between those 2 points. Any instance of the bullet's collision check after that is going to be between that second position and a new position, and it's going to cycle through that. So what's going to happen is this is T1 and this is T2. What's going to happen is, if I go over here, we are going to, this one's going to be done. So let's get rid of that. And then there's going to be a new bullet over here, or a new position check of the bullet. And what's going to happen is, between those 2 points, what's happening is it's checking the positions in that way, where this positions array is essentially an array of vector 3s, but it only has 2 spaces in it. So it's getting the current position and the next position. But what's going to happen after that initial position is checked, it's going to take the second position, which is right here, and it's going to reassign that as position 1, and then it's going to take that one and assign that to position 2. So it's going to cycle through and keep doing that. So that kind of saves on having to calculate that second position over and over again. It's kind of switching them between it, and that data can be reused. And essentially that makes it so there's no gaps in between when the collisions are being checked. So that's taken care of. Going past that, we have the ray direction, which is between position 1 minus position 0. So the second position and the first position. So we're getting the vector towards it. And the ray length is the magnitude of that vector, so the distance between them. And essentially getting that distance is also calculated by dividing the ray direction into the ray length. We are taking the raycast all, which is grabbing multiple hits and putting that into the hits kind of array here. So it's raycast hits array, which is indicated here, called hits. And then for each of those hits, we are going to check if it has a hitbox and if it is the main player. And the reason we check if it's the main player, we do not want the bullets hitting the player if they haven't reflected off of anything yet, because in very specific scenarios, the character might be moving at incredible speeds, and if you're moving in the direction that the bullet is firing, the bullet isn't going to inherit the velocity of the character, so you might be moving faster than the bullet would even be moving, so you might hit yourself that way, and that would just be silly, and we wouldn't want that to happen. So essentially, we are not going to inflict damage on the player unless the bullet has reflected at least once. So you can reflect off a wall and end up hurting yourself or killing yourself like in Halo. But if it is not the player, then we're just going to apply the damage to it. So we're getting the hitbox, which is in here, and we check the hitbox, player hitbox component, and it's a very, very simple component. It has a player manager, which is the parent, and the multiplier identity, which if you just type the word head into it, it will apply the headshot modifier. So essentially, it just needs this player manager parent. And it's kind of silly, but kind of not. It's kind of silly to apply this to every single hitbox object. You could maybe have a static one, but that would be useful in, say, an instance for a single player game. But if it was multiplayer, we wouldn't really want it to just use every single hitbox regarding the main player. So it makes sense to have specific player managers that are being assigned to each of the hitboxes, especially if you have a very involved kind of game that takes the regular player manager and uses that for the enemies, like Unreal Tournament or Halo Infinite, those kind of things, or anything with bots. I think Call of Duty Black Ops 2 does that. I don't know if anything after that does that, but it kind of also adds that immersion and a sense of fairness when the capabilities of the enemy are the same as the player. So back into the bullet script. So it's checking if that multiplier identity is equal to head. If so, it's going to add headshot bonus on there. If not, it's just going to do the regular damage, and we're multiplying that by -1 because the way the script works is it is taking an integer and it is adding that onto the health of the player. So we have to multiply it by -1 to kind of do it that way, because that script can also be used for picking up health packs or healing other players. So it's a very versatile script. You just have to include whether it's negative or not. If the object has a mesh render and that mesh render is enabled, then we're going to run the kind of reflection script. So we are going to get the hit angle, which is going to be the angle between the ray direction and the negative normal. So we're getting the kind of direction the wall is facing, but the opposite. And we're getting the angle between the direction the bullet is heading and that angle. So then we are generating a random number between 0 and 100. If that number is greater or equal to 100 minus the hit angle and that reflection modifier, then we are going to reflect that bullet. And essentially we have some VFX that play for that. And we are just changing where the VFX of the impact, like decal thing and stuff, are going to spawn. But the only difference between whether or not it's going to reflect and whether it's going to hit is that the direction of the bullet is going to change. So we're going to change the direction of the bullet using this reflect bullet function here. Basically what we're doing is we're grabbing a reflection vector 3, which is going to be vector3.reflect the direction and the hit normalized, so we can add any kind of multiplier we want onto it. And essentially we don't want to have a non-normalized vector there because it may increase or decrease the speed of the bullet, and we're going to handle that here later, because what I like to do is as it reflects, the speed decreases. It is cut in half every single time it reflects. And we have an amount of reflections that are on there, and that's very simple. On the bullet we'll have a script that says adds the reflection count, like right here, and if the reflection count reaches a certain amount, then we will just destroy the game object. And when we change the reflection of that, or the direction of that bullet, essentially what we're doing is taking the rigid body and changing the velocity to that reflection angle that we got, multiplying it by the velocity of the object. So we're taking the velocity as it hits and then redirecting it. And that's essentially what's happening with the bullets here. And if it hits the enemy, it deals damage, and it also reflects. So you can have it reflect and deal damage to an enemy. But I'll probably change it so that it doesn't do that, just so that we can have some kind of piercing, very reliable piercing in the game if you wanted to get collateral kills. But maybe keep that activated for characters with armor or something. But overall, this system works very well. It's not super intensive on the CPU or anything like that. You could shoot like 100 of these bullets and lose like 5 frames or something like that, which isn't ideal, but that's shooting 100 of these bullets at once. If you're just shooting them over time, then it still works. So essentially, something else that's very important to mention is that this will not work with this hitbox system if the parented object has a rigid body. The impact of the rigid body, that detection will always override something like a raycast all, and what will be returned, even if you're trying to detect everything between that ray and that object, you will return just that rigid body. And the way to get around this is if you go into the character, anything that you're adding this rigid body to, if we go to this character right here, we have the hitbox script, and normally that would be enough, but we have to add a rigid body to it and make it kinematic. So this rigid body is going to be detected along the as well as the rigid body that's on the actual character. And the only one that's actually going to deal damage is the one that has the hitbox script on it. So that's important too. So this is all very useful for a like first-person shooter type setup, and hopefully you find it useful. I put a decent amount of work into this, and I think that it works really well. So feel free to copy any information you see in this video. If it helps you make your project, that's what's most important. And I hope you have a nice day. Hopefully this helped. Make sure you follow me on my Twitter, which is of the same name, LowResDev, no space, no underscore, or anything like that. I am being more active on Instagram of the same name. Twitter has the same name. Tumblr is the same name. I also post on Reddit every once in a while, but I think that one has like underscores or something between it. It'll be very easy to find me on there if that's what you're looking for. But it would really help to follow me on any of these social media things, because I'm trying to kind of gather followers and make more of these videos. But please, if you can, like the video, favorite it if that's still a thing, subscribe. Most importantly, subscribe on here, because this is where I'm planning on putting all my long form videos. Thanks for watching, and I'll see you in the next one.